Hello my people. So, can you answer an inequality exam question within seconds? Let's establish that. So, for you to be able to answer a question in a few seconds, you need to capture the notation. There are two basic notations. After you have been given an equation, you've done all the factorizations and you have your critical values, there are two notations. Right, let's look at this. The first one is this one, not necessarily in importance, but that's the first one. If it is not this one, the other notation would be what? Would be x is less than a certain value or x is greater than a certain value. All right, so if you capture that, now you have to capture two scenarios. Whenever we have an equation, a quadratic equation, we can represent it as a graph, isn't it? So there are two scenarios. You have a graph of a positive function. And if this is the situation, you need to be able to navigate correctly when you come to this situation. Right, so I am going to redraw this once more, this side, so that you understand when to use any of those two notations. So, if you are given an equation, you have a positive gradient, your ax squared plus bx plus c, and you have factorized it properly, and in that equation, the requirement was for you to solve and find those x solution that will give a negative output. So when you've done that, you would have your critical values. The left one would be the smallest. The smallest value will be this side, and then the largest will be on that side. So if you have your values, let's say this one is C, that one is V. You now have to find Y values that are negative because of that condition. And if we have to see the graph, where is our Y values negative? If this is our X intercept, we know that all the negative values will be this side. And on our x-axis, where do these negative values start? They start there and then they end there. So in the end, when you've done, what are you going to say? You are going to say x is between those two values, isn't it? This value and that constant there. Then you would be done. All right. Now, if they say they give you this same equation, they say we have this equation. Now, what do we want? We want you to give us those x solution which will give us positive outputs greater than 0. Same scenario, but different requirement. Now, what are you going to do? Same situation. You will have the smallest factor this side or root, then you would have the largest that side. Then what is going to happen? Where are my Y values positive in this graph? They would be there, isn't it? So they are going this direction because all my positive are there on that graph. So your conclusion is what now? My x solutions start from where? They start from there, isn't it? So if they start from here, which direction are they going? They are going that direction. Where are my x values? This side, they start here, they are going that direction. How do you notate that? It's as simple, isn't it? The x values that I have are greater than that value, isn't it? And then the other ones are less than that value. So you have to use this notation. So you are going to have another situation, constant or value. So what are you going to say now? You are going to say x is less than that value, or x is greater than that value. Then you'd be done. So if you understand this basic situation, you will be able to secure your marks. You'll be able to finish this within seconds. Now there is just a special condition which I can just squeeze in here. What is that condition? This is this condition. When you have a graph with equal roots. Okay. So if you have equal roots, what is happening now? All my solutions are everywhere, isn't it? So if they say they want solutions for what is it, a function to give us output that are positive, where is this happening? It's happening this side, it's also happening that side. So here you will have x is an element of all real numbers. Okay, this one I will just discuss in different video. Then the other one that I will discuss in a separate video are equations that have a negative gradient. Right, so for now what we'll do, we'll just take a few examples. Right, hang in there. Alrighty, my people, let's take our first example. So you are in an exam and they give you something like this, and as you can see, it's only 2 marks, isn't it? Okay, now I've shown you in the schemas of the diagrams that all you need to be conscious of is the gradient. Okay, so if you see that this one, when I multiply it, it will be x squared, so it is a positive gradient. So you get to this, check your your video there as you watch it, check the time, and then see how much time I take. Right, so you get here, you start, then you get to this one, you say, in my reading time I saw that this one, it's already factorized for me, that's why they only give me 2 marks. And then you can say, I know that whenever I get less than 0, my graph is below, isn't it? So which is the smallest amount? It will be 0, because 4 will give me a 0, so it's there. Then you are done. Okay, do they want more? No. Okay, they want the solutions. Do you have the critical values, and is it the right notation? That's all. Few seconds. Right, now if I can just demonstrate this, we saw there, I'm just redoing this. So if this is my x squared minus 4x, what's going to happen now? This is x squared minus 4x, so it is positive, isn't it? So where is my function going to be negative? It's going to be negative there. And where will that be? It will be between 0 and 4. Okay, so you can just do the smiley quickly so that you can see, then you know that my interval is between my critical values, and you are done. Okay, right, all of this as I've explained in the other video, x is equals to 0, what is it, x minus 4 is less than 0, x is less than 4. Right, it's going to waste your time. This is not grade 10. You don't have 5 marks or 3 marks or 4 marks as in grade 10. Okay, right, so let's look at our second example. Alrighty, there is our next example. Now, let's look at what is happening here. So this one is how many marks? As you can see, it is 5 marks there. Alright, so it means there's spade work to do. So you get to this and then you are going to start, check your clock there. Okay, so 1.1.3, then you will write there inequality as given. Then what do they want to see? They want you to follow convention. Write that in its standard form. Then what must you do now? You must factorize. So if you are stuck with the algebraic equation, you are going to waste time. Here, I don't have any other factors of 5. It is only 5 and 1. Then what do I do here? I want a 21. How can I get a 21? I get a 21 by multiplying 4 and 5, isn't it? Okay, so if I multiply 4 and 5, what will I get? I'll get a 20. And then if I multiply 1 and 1, I get a 1. So I'll get 1x. Then my sign is positive. For me to multiply 2 brackets to get a positive, I get a negative and a negative. Because those 2 negatives, when they add, they must give me that. You are done. Right. Without talking, I would have long arrived at x is equals to 1 over 5 or x is equals to 4 as my critical values. Okay. Then what is happening now? It is a positive gradient. I know that my graph is positive above, and when I am above my x-axis, my graph is positive on the left of my smallest critical value, or it is greater than the bigger critical value. Then I'm done. Okay, few seconds. Let's check what I'm talking about. I have my graph there. I have 1 over 5. And then I have a 4. So I am looking for positive values. Where are the positive values? They are there. Where do they start? Here, my graph is negative. They start there. So it means it is greater than that one, and it is less than that one. It's as easy as that. Righto. So is maths not so easy peasy? It is. So can you do this in a few seconds? Yes, you can. Are the notations still worrying you? No. All right. So with these 2 examples, I hope that you are able to capture the basic of this. The only thing that you can do now is to say, okay, if I want to be sure with this, I must go and do what? I'm going to go and use those other 2 methods where I do what? Where I test, where I put my critical values and I say I am going to take a value that is less than that one. The first easiest one would be what? Would be a 0 on the number line. Then in the middle of this, I can take 1. Okay. Then I can take a 5. So you put it in your calculator, check what these give you, and then you want those ones which will give you outputs that are greater than 0. Okay, so this method is quite long. This other one is the same method of using your number line. You put 1 over 5, you put a 4. What number is there? A 0 is there. What number follows a fraction? 1. What number follows a 4? 5. Then you go to your calculator, waste of time, because you must put this in a calculator, check the answer. Put this in a calculator, check your answer, and so forth. Okay, right, nothing wrong with that whilst you are still developing, but when you get to your matric and your exam, that's my best bet for you. Then we can also do another video where we also use a calculator, just a calculator, so that you can see that if all of these still don't make sense for you, how can a calculator rescue you? All right, so we will now do a video. Just check the video where I now give an example on a negative negative function. Alrighty, I hope you are fine now. Thanks for watching.